reality is actually human awareness, and that we actually create the world with our awareness, because, at least according to certain interpretations of quantum mechanics, a particle actually doesn't decide where it is. It can be in many different places. But when we observe it, we resolve that quantum ambiguity, and reality actually becomes manifest as a result of observation by a conscious observer. There are other interpretations of quantum mechanics, but it's interesting that there actually is a meeting of the minds between certain schools of Eastern thought with certain interpretations of quantum mechanics. And there's also, there's been speculation by scientists such as Roger Penrose that human consciousness arises from quantum interactions that take place in our brain. People pointed out to Penrose, well, the brain is actually a pretty messy place, and the neurons are not really at the right scale for quantum events to take place, or for there to be quantum ambiguity or quantum entanglement. So he came up with a theory that the tubules, which are very fine structures within the neurons, do quantum computing. That remains controversial. We've never actually detected quantum computing inside the human brain. My own feeling is, if we look at what human beings are capable of, we don't see evidence that we're doing quantum computing, because quantum computing would be able to simultaneously consider every possible combination of solutions to a problem simultaneously. And the kinds of things that humans do seem to be explained by more classical computing. But this remains both a technical and controversial area. I would approach spirituality a little differently. I mean, I'm quite enamored with the powers of evolution. In fact, we can use evolution in a computer and actually simulate evolution, and the computer will actually evolve an intelligent solution to a problem. It's really quite amazing. We let millions of solutions compete in a simulated environment, and it comes after hundreds of generations. It actually evolves a surprising and intelligent solution to a problem. So biological evolution gave rise to a technology creating species, and evolution is actually capable of creating more complex, more intelligent entities than you started with. And then the technology creating species has ushered in this whole evolutionary process of technology. And that has enabled us to, and that is actually the cutting edge of evolution right now on Earth. I mean, biological evolution is continuing, but we are making 1,000 times faster progress with technological evolution. And ultimately, that is the way in which we're going to lift ourselves up. And what happens in an evolutionary process? Well, things get more complicated. The entities actually get more knowledgeable. They get more creative. They actually get more beautiful. They get more capable of higher level emotions like love. So they become more knowledgeable, more creative, more beautiful, all the things that have been attributed to God in our religious traditions without limit. And an evolutionary process actually never reaches infinite levels, but it explodes exponentially, and so it seems to be becoming infinite. Literally stays finite, but it explodes in capability, moving closer to that ideal of infinite knowledge, infinite intelligence. So you could say that evolution is a spiritual process, and I believe that's the case. I mean, you asked before what is the purpose of all this, and I really see it as a spiritual process to expand knowledge. But knowledge is not just information. It's not just dry fact. Knowledge is expressions of a loving sentiment, art, music, science, the grand expressions of human civilization, and that is a spiritual quest, in my view.
One of your titles of your books is called The Age of Spiritual Machines. What do you mean by a spiritual machine?
Well, I was making two allusions. One is to this concept of spirituality that I just articulated, that an evolutionary process, starting with biology and now with technology, is actually moving towards greater levels of intelligence and therefore becoming more like God, at least moving in that spiritual direction of greater intelligence. So we could say it's a spiritual process. But there was another allusion. I mean, what do we mean when people say, well, a person has a soul? They're really referring to consciousness, the fact that I'm aware of my own existence. I'm not just aware of it, I feel it, and I feel the emotions associated with it. And these emotions are not just technical states, they're rich in meaning, and that is, so human beings, I mean, are a machine. I mean, a neuron is a collection of molecules and ion channels, and you can describe, and we are, in fact, describing those in very precise terms, and you put 100 billion of them together in a very specific way, and you create a human being, and a lot of people would consider a human being to be a spiritual machine. Well, we're going to be able to recreate the powers of human intelligence, all of the subtlety and suppleness of human intelligence in a machine. And therefore, those machines, I mean, if human beings, in fact, are spiritual machines, and those machines that emulate human intelligence and have the same complexity and are based on the design of human intelligence will share in that property. And then you ask the question, okay, well, is a machine like that conscious? Well, how can you tell? Well, let's ask the machine. Are you conscious? So the machine says, yeah, I'm conscious. Well, a machine could say that today. Do you believe it? Well, today you don't believe it. When a character in a video game says, I'm very jealous or I'm very angry at you, you don't really take it seriously because we can see the edges of its intelligence. They're not fully convincing. They don't have all the subtle cues that go along with that emotion. So we don't really believe that they're really conscious. We think they're just a software program. But the point of my thesis is that as we get out to the late 2020s, early 2030s, these machines will be so complex and so rich in their emotional reactions and so realistic in their recreations of human intelligence that when they talk about their feelings, they will have all the subtle cues, and we will be convinced by them. But ultimately, this is not a philosophical proof that they are conscious. Consciousness is a synonym for subjectivity, and science is really objectivity and rational deductions from our objective observation. And there's a gap between science, objectivity, and subjectivity. And there's really no scientific test we can postulate that we could slide an entity in and a green light comes on. Okay, this one's conscious. No, this one's not conscious. We could build a machine like that, but it would have philosophical assumptions built into it. So John Searle would make sure that it's squirting neurotransmitters, and Roger Penrose would make sure that it had something equivalent to the tubules during quantum computing, and other scientists or philosophers would make other assumptions. But there's really no objective way to absolutely answer that question. And we don't even know that other people are conscious, but we assume that. But actually, when we go outside of shared human experience, talk about, for example, animals, we're not sure, or at least we disagree. And we'll have disagreements about these machines.
Someone who disagrees with you is on the line from Knoxville, Tennessee.
Hello. I am a material scientist. I work at Oak Ridge National Laboratory. I'm a big fan of BookTV, and the reason I'm calling today is to express my disappointment that you have invited this highly sophisticated crackpot and given him a national forum to express his pseudo-religious predictions that have no basis in objective reality. And I'll just point out two big problems with what he says. The first is that he believes evolution is progressive, but he offers no evidence for this claim. He says that it's getting more complex, but he doesn't offer an objective measurement of complexity that he can show is following some trend. And even if there is a trend, random phenomena can produce things that look like trends. It doesn't mean that there is one there. You have to show that we were produced, our species was produced, not from random mutations, which we know this is how natural selection works. He presents a plot in his book where he shows it exponentially accelerating. He uses species and genus and family and group that our species came from. But you can produce the exact same plot for any species. They'll all show exponentially accelerating trends if you just use their taxonomic branching points. I'm sorry to get technical here. It does not prove that we were the products of an exponential trend. It actually arises out of the statistics of natural selection. The second point is that small is almost always more expensive. Imagine if you were asked to produce a replica of the chair that you're sitting on. You could probably go to Home Depot and get the tools to do this, and it wouldn't be that expensive. Now imagine if I asked you to produce a replica of the same chair, except that is the size of a grain of salt. How would you do this? What tools would you buy? You'd maybe use a couple lasers to polymerize the liquid, but it would be much more expensive. And this is the trend. A corollary to Moore's law is Moore's second law, which is that these production facilities are getting exponentially more expensive. It doesn't matter what you do, just from the second law of thermodynamics, small is going to be more expensive. I have also problems with Mr. Kurzweil's estimation of the computational power of the human brain. He doesn't consider processes like phosphorylation, where individual proteins can act as molecular switches.
Okay, caller, thank you.
Well, you bring up a number of interesting issues. If we look at biological evolution, go back billions of years, and bacteria, single-celled organisms were the cutting edge, were the most complex and most intelligent entities. We then went to multicellular organisms. We then went to more and more complex ones like lizards, and then finally mammals, and then primates that actually had, and then there was the evolution of cognitive functions, and then the evolution of Homo sapiens. There's been a continual acceleration at every pace. Evolution works through indirection. It creates a capability and then it uses that, and that's why the process accelerates. So it took 1 billion years to evolve DNA. Actually, RNA came first. Then evolution used DNA. So the Cambrian explosion and all the body plans of the animals evolved only took about 10 million years. And then higher cognitive functions evolved in only a few million years. And then Homo sapiens evolved in only a few 100,000 years. And then we moved to technology evolution, where the first stages like stone tools, fire, the wheel, took only tens of thousands of years. And that has continued to accelerate because we always use the latest technology to create the next. 50 years ago, computers were designed pen on paper, wired with screwdrivers. It took years to design the first computers. We now use computers and 10th generation computer-assisted design software to design computers, and you can design a new computer system in days. And there's been a continual acceleration, and I review that in a number of different ways. And in terms of your points on nanotechnology, the key features of technology have been getting smaller and smaller. We don't have the tools now to create full-scale, massively parallel molecular nanotechnology today, but we're moving in that direction. The key features of technology are getting smaller, declining by about 100 per 3D volume per decade, and I make that case in the book. At that rate, we will get to full-scale molecular nanotechnology in about 20 years. At that point, we'll be able to create macro objects, designing them at the molecular level, and these will be self-organizing. The counter trend to the second Moore's law, where these fabrication facilities get more and more expensive, is that chips will be self-organizing. And that was actually a controversial notion when my book Age of Spiritual Machines came out in '99. There's been so much progress in that it's very much a mainstream view. You can talk to the Intel scientists. In fact, I was just at IBM recently, and they showed me some self-organizing molecular circuits that are beginning to work in 3 dimensions. A nanotube-based memory is actually going to hit the market next year, which uses self-organizing features. So we are actually moving in the direction of being able to create in very small facilities, desktop facilities, that can actually create 3-dimensional circuits that are not chips, but are actually self-organizing, the self-diagnosing work. The latest generation chips actually has self-healing and self-diagnostic capabilities because they're so massive that they don't want to throw the whole chip away because one transistor is broken, so they're actually able to route information around that information. The internet is based on that. The internet hasn't gone down for 1 second in 10 years because information routes around damaged portions. So, I mean, the whole book makes the case for these exponential trends quite extensively through 600 pages. I can't summarize all of it.
So going back to the concept of what he brought up of nanotechnology, is it fair to say it's a little robot? Is that what we're talking about when we're talking about a nanobot or whatever?
Nanotechnology